There we go. All right, you see my screen, right? All right, so we're going to be moving out of the real number system. We're wondering, well, why would we do that? Is this writing correctly? Yep, good. Okay. Yeah, do all that in this. So, imaginary numbers. The name is a little deceiving. Because you might think, well, why, this isn't like a fairy tale set of numbers. It's actually quite useful, especially in engineering. And the one thing that we all hopefully know is that you can't not take the square root of a negative in the real number system, right? Let me just, before we get going on this, let's do a quick note. Just to lay a little groundwork here. So go to that notes page over here. Okay. So in the set of real numbers, we cannot take the square root of a negative, right? In the set of real numbers, right? Remember, it's the symbol for real numbers is this double-lined R thing, okay? We cannot take the square root of a negative number. Cannot take square root of negatives. Okay? So, for example, if I ask you to take the square root of 16, right? You know that's plus or minus 4, right? Two answers, right? And why is that? What does that imply? Right, that the square root of 16 is plus or minus 4. It implies that when we go the other way, 4 squared, we get positive 16, right? And if we square negative 4, we also get positive 16, don't you? Right? Because anything we square, we always end up with a positive number, right? Everybody with me? Okay, so let's talk about taking maybe the square root of negative 16. Okay? Well, we know that's undefined, right? Well, why would that be undefined? Why can't we do that?
Because there's no root number.
Right? Because it's undefined because no real number squared
it's the root of it.
No real number squared will become negative, right? That makes sense? Okay? But as it turns out, in certain fields out there, I think probably like electrical engineering and some other applications, as you're working through certain problems, that you end up having to take the square root of negative numbers. And so what do? Well, they came up with this this little fix, okay? It's a whole different set of numbers, right, other than the reals, okay?
Quick question. Are you recording this?
I believe so, yes.
Okay,
Yep,
I was wondering if I
that's
can
no,
see
no.
that.
Thank you for checking. Sometimes it doesn't stay on top. I don't know why, no rhyme or reason to it. So if I wanted to take the square root of some negative number, negative a, okay, that can be handled with what's called imaginary numbers, okay? Square root of negative a can be handled with imaginary numbers, okay? So let me take a look at a oh, and by the way, that imaginary number, right, is this lowercase letter I standing for imaginary. Let's show you the graph of something that has solutions, right? Let me just box this in because that's kind of important. Why do they do that? So if I was to graph a function, I don't know, like some kind of quadratic like this, hopefully you guys know, like from algebra, that the zeros of the function, right? Where it hits the x-axis, where y is 0, those are the solutions, right? So this particular graph, whatever equation gave it, it has zeros, like 2 of them there, right? In other words, these are real solutions, real number solutions. Right? So you could, solve the equation and get the values of these two intersection points on the x-axis, right? But what if this graph got shifted up? Because we talked about shifting, right? What if whatever equation we had was whatever it is, x squared, plus 10, and it's way up here. Does this intersect the x-axis at all?
No.
So does it have any zeros?
No.
No, it doesn't have any zeros, right? So there are no zeros for this function, right? Which means it has no real solutions. And I'm emphasizing the word real. No real solutions. Okay? Because it does not intersect the x-axis. Okay? But we can handle this with these imaginary numbers. And if we go back to the first page of this here, let's take a look at the setup here. Okay? Everybody got this written down? Or do you need a second? All right, let's go back. You can always get it off Teams later on. All right, so let's look at this first exercise. So exercise 1. Down here on the coordinate plane, they have a sketch of y equals x squared. It's a parabola, right? And this parabola intersects the x-axis down. It looks like it hits it once, right? So it's got at least a 0 there, okay? And now they want to consider the parabola x squared plus 1. All right, well, what does adding 1 outside the function do to that graph?
And shifted it up 1.
Okay. So the answer to part A is how is that shifted, right? It goes up 1, right? So over in part B, they want us to make a quick sketch of this graph of x squared plus 1. So let's move it up 1. So I'm going to we'll call that mark 1 unit up, right? And so then our graph will kind of look like that, right? Are you with me? So now, does that graph intersect the x-axis?
No.
Okay. So in part C, what can be said about the x-intercepts of the function? Are there any?
No.
So there are none.
There are no real solutions.
Right, right. So that equation, x squared plus 1, has no real solutions, right? No zeros to the function, which is also known as solutions. And I want to emphasize in the set of real numbers, right? Symbol for the real numbers. So to find zeros, right, to solve an equation, it needs to equal 0, doesn't it? Right? And then you solve it. We did it yesterday with the quadratic formula, right? They had to equal 0, and then you can solve it. So let's look at part D here. So algebraically show that these intercepts do not exist. So they want us to show algebraically that that cannot be solved in the real number system. Okay? Well, to solve that for x, what would be the first thing we do? This x squared plus 1 equals 0. What would be the first thing we do?
We would minus it by both sides by 1.
Well, we'd subtract 1 from both sides, right? And we'd end up with x squared equals negative 1, right? And then what do we do?
Then we square root both sides.
So then we end up with x equals, all right, plus or minus the square root of negative 1. Uh-oh. Is that valid?
No.
That's undefined, right? Because it's a square root of a negative. It's undefined, let's be specific here, in the real number set. Okay? But we can handle that. So we need something to equal the square root of -1? Well, that would be this letter I, okay? Imaginary numbers, okay? So we can now take the square root of -1. If you look down here, it says I equals the square root of -1, okay? This is important here. This is the whole crux of the lesson, okay? So whenever you have the square root of -1, it can come out as an I. But in other words, let's see. Maybe I'll put it in here. So if I have the square root of -1, that equals I, right? I just wrote it the other way. But what would I squared equal? If I equals the square root of -1, wouldn't I squared be square root of -1 squared? And what is the square root of -1 squared?
It would be -1.
Yeah, right? Squaring and square roots undo each other. -1. So look at that. If I take that imaginary number, that square root of -1, and square it, I end up getting a -1. And so that's one of the things, like, as an electrical engineer maybe, or whatever field you're in, and you come across a square root of a negative, well, you handle it with an I. And then you kind of hope as you proceed through your solution that somewhere along the line you square that I, right, and get a real number. If that makes sense. Well, let's look at some examples here, okay? They want us to simplify these, okay? So part A, we've got the square root of -9. Let's break that up like we do, right? So that would equal the square root of 9 times the square root of -1, right? Kind of like we did yesterday. And what's the square root of 9?
That would be 3.
So it'd be, we'll title it plus or minus 3, and the square root of -1 is what?
That would be undefined.
Well, no, we're going to use our new number set.
I.
So the square root of -9, we now have a way to handle it. It's plus or minus 3I. Because what does I equal?
I equals square root of -1.
Right? Okay. So now we can handle these square roots of negatives. Let's try the square root of 100. Well, that would be the square, or -100. Square root of 100 times the square root of -1, if we, break it out there. And what do we get here? What's the square root of 100?
10.
Well, remember, plus or minus 10.
Okay, yeah.
And I for the square root of -1. You with me? Okay, let's look at the square root of -32. Now, -32 is not a perfect square, right? But is there a perfect square factor of 32?
Yes.
What's the biggest perfect square factor of 32?
16.
So we could write that as
Square root of 16
16
the square root of
2.
-2.
Well, and let's just separate out the -1 for now, right? Eventually, when you get a little comfortable with this, you won't have to separate out the -1. You'll just put the I in there, right? Okay. So let's rewrite it. Square root of 16 is what?
4.
4. And let's do the square root of -1. What's that? Well, plus or minus, by the way. Plus or minus 4I square root of 2. We like to put the stuff before the square root. You can multiply in any order, right? Everybody with me on that?
Yeah.
So let's take the square root of -18. What's the biggest perfect square factor of 18?
9
Okay, times what?
times 2.
Yeah.
Square root of 2 times the square root of -1.
Right? So wouldn't that leave us plus or minus 3I times the square root of 2? And we've handled the square root of negative numbers. Does anybody have any questions on this so far? Good? Let's go to the next page to see if we can solve some equations now that might result in the square root of a negative. From page 138. So let's solve these now. We got 5x squared plus 8 equals negative 12. Well, let's go ahead and subtract 8 from both sides, right? And if we subtract 8 from both sides, we have 5x squared equals what? It's negative 12 minus 8, guys.
20, negative 20.
Negative 20, right? Right? We should now divide both sides by 5, right? That gives us x squared equals what? Negative
4.
4. And now we take the square root of both sides, right? So we get x equals the square root of negative 4, right? I don't think we need to break out the negative 1, do we? So what's the square root of 4?
Plus or minus 2.
Plus or minus 2, what?
I.
I. There you go. We now have a solution to an equation that we couldn't solve previously. Plus or minus 2i. All right? All right, let me give you guys a chance to try B and C over here, okay? So you guys take a minute, solve B and C, and hopefully you know. Is anybody confused about how to handle taking the square root of a negative now? All right, so I'll give you a minute or two. Let's work through that in case somebody else didn't quite get that. So we'll subtract 20 from both sides. We got 1/2 x squared equals negative 18, right? Then we can multiply both sides by 2, get rid of that half, yeah? So we get x squared equals negative 36. So x equals the square root of negative 36, right? And well, square root of 36 is 6, right? So but then we got that negative, so plus or minus 6i. Any questions on that one, anybody? Okay, I'll give you a moment on part C. Just run through this real quick. Add 10 to both sides, right? 2x squared equals negative 26, right? Divide by 2, we get x squared equals negative 13, okay? So x is going to equal square root of negative 13. The only thing that can come out of there is that negative 1 as a what?
X equals plus or minus 1.
I
I.
times the square root of positive 13. I took the negative 1 out of the square root, right? Now, some of you might like to write it as square root of 13. I prefer to put stuff in front of the radical, and the reason for that is if you're writing, because some of you have horrible writing skills, and you might have the I, or is it in the square root or is it not in the square root? You see what I mean, right? And so you'd have to be really careful to have it clearly out. So it's easier just to put it in front. Does that make sense? Most of the time, put stuff in front of the square root. So you guys had a little struggle with that one. Do you see? I guess I'm curious. What is it that kept you from including the square root in the 13? What was the thinking?
I thought it was mostly because we had to get rid of the 13. I didn't think we had to put that in the answer.
No, we don't need to get rid of the 13.
Not like that square root.
We don't need to get rid of the 13. We just need to get the x by itself, right? Yeah. Okay. It's just 13 is not a perfect square. It doesn't have any perfect square factors, right? So it has to stay in there. And the negative 1 comes out of the square root as an I. Okay. All right, let's take a look then at the next one here. And you'll remember something I said a few minutes ago back on the previous page. So they want us to figure out what is 5i times 6i. Let's see here. What would that be? Just, you don't have to write this down. What if it was 5? Good gravy. Why does it do that? Stupid thing. What if it was 5x times 6x? What would you get, guys? You don't need to write this down.
40x.
It'd be 30 what?
40x squared.
30x squared, right? Okay, so we're just, instead of x, you're going to use an I, aren't you?
That makes it 30i squared.
So that would be 30i squared. But what does I squared equal, guys?
It equals 1, like the square root of 1.
Well, okay, let me go back here. If I is the square root of -1, then I squared is that thing squared, which is what? What's the square root of -1 squared, huh?
It's -1.
-1, right?
So it'll be -30.
So 30i squared is 30 times -1, right? You with me? I squared is -1. So the answer here is what?
-30.
-30. Okay, you with me there? And that's kind of what you hope, you know, when you're actually working on a real life problem. If you end up with i's somewhere in your solution, you're hoping that you end up having to square it at some point. And then you get a nice real number. Okay? Now, exercise 5, I'm not going to go through all of these. The one important thing that we need, we just kind of covered it, right? We know I to the first power equals I, which of course, let's just emphasize this, is a square root of -1, right? But this I squared, you're going to see it again because this is kind of important. I squared here is the square root of -1 squared, which is what, everybody?
-1.
-1. Okay, so this one is important. I'm not going to worry about all of these guys right now. If we were in a full course, I'd go through all that. Okay. All right. So does anybody have any questions on this section? We're going to skip exercise. Exercise 6. We're going to skip 7. So we don't need to deal with that right now. Okay. Does anybody have any questions on taking the square root of a negative number? You can't do it in the real number system, but we can use what kind of numbers to do it?
We can use the imaginary.
Imaginary, right? Lowercase I. All right, let me give you your problem set then, because it's not going to be all of them. Okay? So your problem set, you're going to do numbers 1 through 3, 5 through 7, 8a, and 11. All right, so make sure you jot that down. You stop the video while you're writing that down.